Welcome everybody and hello to our very first serverless webinar. Thanks for tuning in and thanks for following this webinar. I can promise you we've prepared lots of interesting and exciting content for you. Before we start, let me shortly introduce myself. My name is Sebastian. I'm guiding you through the program here and I do a little moderation. By the way, I'm also the organizer of our Serverless Architecture Conference. And the idea of this serverless webinar is to give you on the one hand a glimpse on what serverless technologies can mean to you, to your company, to your customers. On the one hand, and on the other hand, of course, to give you a little taste from what you can expect from our serverless conference. As I just mentioned, the conference, it's going to happen in The Hague, in beautiful Netherlands. In the week of April 8th. And I can promise you we collected lots of interesting content, lots of really excited and exciting speakers presenting their talks on various aspects on serverless technologies. The basic idea of the conference is to look on modern cloud infrastructure, not only in the sense of serverless, which means not only looking like function as a service and Amazon Lambda technologies like that, but we also look, for example, to different managed services on the different cloud platforms, or at the same time to the Kubernetes ecosystem. But we do this all from the perspective of software architects and software developers. So of course we do this all in the spirit of DevOps, but this is not a DevOps conference because we do not go really into the technologies. It's just the development and deployment view. This conference, as I said, you can visit the website on serverless-architecture.io. Here you find more information. And of course, as you are followers of the webinar, we have an exclusive offer especially for you. If you want to register for the conference, which we'd be very happy about, of course, yeah, you can use the promo code Serverless Webinar 19. And by using that, you get 10% off the conference ticket price. Use Serverless Webinar 19 and you get 10% off. That was it about the conference. Now let's get back to the little webinar. We've invited 3 speakers with interesting talks. Every talk is going to last about 15 minutes like that. So the entire presentation is going to be finished at, let's say, in more or less 50 minutes. And after that, in case you get any more questions, there's some time to discuss your questions. Maybe you want to understand a little bit deeper what they are telling you. If you want to raise a question, go on Twitter, use the hashtag #serverlesswebinar. Serverlesswebinar, just in one word. We are following this hashtag. And of course, my colleagues here helping me to put your question into the conversation. That's it from my side. And now it's a pleasure for me to announce the speakers we've invited. As I already said, all of them, they are also speakers at the conference. You can meet them in The Hague in the week of April 8 if you want. First of all, let me introduce Billie Thompson. She's a cloud native consultant, helps devs and organizations to get into the game of modern infrastructure, of microservices. And she cares about technology on the one hand and about, let's say, methodology in the sense of domain-driven designs and things like that on the other hand. Hi, Billie.
Yeah.
Secondly, let me please introduce Christian Weyer. He's the founder of a company called Thinktecture. He's a frequent author and a speaker on many conferences. His background is really, he's coming from the Microsoft world, but now he is kind of a cross-technologist. Yeah, he's not only a Microsoft MVP, but he's also a Google developer expert. And by the way, he's a big fan of vintage computers, as you can see in the back. Hey, Christian.
Hey, hi from Franconia, Germany.
Hey, Franconia. Niko Köbler is, last but not least, the third speaker. He is an independent consultant specialized in Java technologies and JavaScript, and last but not least, of course, in serverless technologies. He has written a book on serverless technologies using Amazon, the Amazon platform, and he's also a very frequent speaker and author, and yeah, an expert in those domains. Hi, Niko.
Hi, Sebastian.
Cool. So then let's just start. As I'm just talking to Niko at the moment, we start right now with Niko's presentation. The title is Serverless Apps in a Multi-Cloud World. Niko is dealing with the challenge of what can I do, or should I really rely on just one cloud provider, or should I rely on multiple cloud providers? What risk does relying on just one represent to me, and what can I do to diversify risk in a technical sense? Niko, please go ahead.
Thank you, Sebastian. Yeah. Hello, everybody. I will talk about serverless in a multi-cloud world, as Sebastian already mentioned. And this is a short introduction of myself. Mostly, Sebastian told everything. You can see at the right cover of the book I wrote, Serverless Computing, AWS Cloud. Unfortunately, for the international viewers, this book's only in German, but I think it's quite interesting. Yeah. Okay, let's start. What could be a reason why you or your management want to have a multi-cloud strategy? Of course, it's the big word vendor lock. And what does it mean, vendor lock? And why people saying vendor lock is bad? I think the vendor lock thing alone, it's not the real reason. It's also missing trust in vendors, missing trust in cloud providers, because you giving tasks to other people and you can't control them. So many people distrust the cloud vendors, and often it's just because the management doesn't have a real reason to focus on one cloud provider only, and then they say, let's have a multi-cloud strategy. We don't want to focus on only one cloud provider. Let's have a look at some vendor lock myths in global software development, and let's discuss these myths. First thing is it's safer to do things in-house. Is it really safer? You depend on your development department, on your operations department if you do things in-house. So you depend on somebody. You always depend on somebody, no matter if it's in-house or from a vendor. Well, you have to pay somebody. Second, open source makes you safe. Yeah, it can be. Open source software can make you safe using open source software, not closed source or specific software, but only if you know your source code. So if in kind of an error, of a vulnerability or something else, you can only fix it if you know your code base. So if you use open source software, open source tools, and you don't know these tools, it doesn't help you in any way. Decentralizations removes the threat of login. So decentralizations in terms of multi-cloud, perhaps. No. If somebody creates a decentralization and creates it very complex, you rely on this one person who knows how this decentralization works. And so if one part of your decentralization doesn't work, your whole system won't work, probably. Login is always a problem. Is it really a problem? Sometimes you even have a login, but you don't know it. If you're using an Oracle database or an IBM database, whatever, or if you're using SAP software, this is also a login. A login, not a login, a login. So you're using software which is really specialized, helping you solving problems, but you can't move from today to tomorrow from SAP to another ERP software. That's easy. And last, lock-in must be avoided at all costs. Why? You always pay somebody, and it depends who you pay for what. And if you pay some specialized vendors for specialized services, lock-in does not necessarily need to be avoided by all costs. So lock-in can also be a good thing. And now let's have a look to vendor lock in terms of cloud. So questions which are asked to me every time I talk about serverless and cloud strategies and whatever. What if my cloud provider gets hacked? I don't know even one big issue in the last past years that a big cloud vendor got hacked. Of course, yes, it is a public cloud, and you have to care for every data, for every software you deploy and use in a public cloud. But also you have to care about the data and software you use in your private data center. And what if your private data center gets hacked? Most probably your private data center has more vulnerabilities than a public cloud provider. What if my cloud provider is down? I don't know a single issue that a whole cloud provider was down in the last past years. There might be a moment when a complete region is down of a cloud provider, but not the whole cloud provider goes down. So when you go to public cloud, make sure to have a multi-region strategy and not to focus on one single region, which might be down at some point. Yes, that might be the case, but not the whole cloud provider is going down. Big question, what if my cloud provider increases the costs? So cloud business is now 10 to 15 years old, and the costs just decreases all the time, and there is still competition on the market, on the cloud market, and there will be still competition in the next 5 to 10 years. So I don't think the costs will increase in the next years. For sure, I can make a promise that's the case, but market says the costs will go down in the next years still. So don't have to fear some cost increases. And what if my management decides to change the cloud provider? Well, what if your management decides to change SAP software to PeopleSoft, or to change the Oracle database to IBM database or PostgreSQL database? Same things apply in cloud strategy. So your management won't get fired for buying one cloud or the another. For every management decision, somebody has to work, unfortunately. So yeah, the last point, I can't give a good answer to this. So after having some theoretical discussion, let's go into some practical API examples. I get asked often when I want to move from one cloud provider to another with a serverless function. What do I have to do, and how are the APIs different? So let's have a look to the APIs between AWS Lambda and, for example, Azure Functions. And first of all, I chose the Java language because both cloud providers provide provide the Java runtimes. In this first example, you can see the plain signature of a Java class with a method. handling a function. So you have plain Java class, no interface, no annotations, no everything. You can just return an object, receive an object as a request. Optionally, you can receive a context object. I come to this later. And yeah, just return some object. You don't have to use special objects. You can use plain object, you can use a string, you can use a map or whatever you like, just an object. This is the base signature of the Java function. And of course, you can use something more specialized. In Lambda, there is an interface, a request handler, which defines the incoming and outgoing object types. And this example is still object. And this request handler interface comes with a handle request method. And so the Lambda runtime environment knows which method to start. In the first example of the plain handler, you have to say, please start the myHandler method. So you can have more than one method in your class, in your handler class. And using the request handler interface in the second example, you just have can have one handler method, the handle request method, and the Lambda runtime knows what to start. And as you can see, the context object is quite interesting. It provides some information about the function currently running, about the runtime environment, the name of the function, the logging name or whatever, and you can obtain a logger of from the context for logging purposes. Why is this important? We will see it later when we come to the Azure functions. And this is a further specialized function with HWS proxy request and HWS proxy response. In terms, you use a Lambda function from the API gateway. So you have still a request handler interface and some specialized request and response objects. But still, you can use just object or map. Also, if you use the Lambda function from the API gateway. So you don't have to use these specialized objects. So let's have a look to Azure function at Java runtime. So the base signature of the Azure function looks completely the same as in Java. So you have a request object, you have a context object, and the return object is also object. So you can run exactly this in Azure, and you don't have to do anything, you don't have to change anything. The context object and the request object, of course, are a bit different in their structure, but from the base signature, it looks the same. So if you build up your functions with the plain layer just for the cloud environment, or so a Lambda environment or Azure environment, and extract all your business logic into separate classes, you just have to change your function handler classes from Lambda to Azure function. And of course, also Azure has some more specialized objects. It has an annotation function name, so the Azure environment knows which method to start. It's similar to the interface in the Lambda environment. And you can tell the function which trigger should be used to start this method. So some trigger is not a real annotation. It's just a placeholder for, let's say, it's a database trigger or HTTP trigger or whatever. And of course, you have the context object. And this example, we'll see, this is an HTTP request response function. Also, the context gives you the ability to retrieve a logger from the context. So this is also the case in Lambda environment. So both APIs are different, but also kind of the same. So the effort to move from one cloud to another is not that much if you separate the API layer from your actual business logic. And if we have a look to JavaScript, Node.js functions, it looks same but different. Both environments have an event or a request object and a context. At the AWS, it's the order is first event, then context, and there's a special callback event. And in Azure, you have as a first object the context, and then the request or event object. So also with Node.js, JavaScript, you have the same object types. And if you separate your business logic from the handler functions, you can pretty simple move from one environment to another. As I already said, the structure of the events and the requests are different, of course. And that's where cloud events may become important in the future. Cloud events is a working group in the Cloud Native Compute Foundation, which aims to have a common specification for describing event data for consistency, accessibility, and portability, so that every cloud provider, every serverless vendor provider uses the same structure for events. An example, HTTP events or database events. So that my function is more easy portable from one environment to another, and the structure of the events keeps the same. So I don't have to change how to get to perhaps the query string of an HTTP event. So cloud events, it's not in the first version, it's still 0.1, I think, and but the working group's working hard to get the next version out, and working together with the Cloud Native Compute Foundation to have a common way for structuring events. And if you have your deployment ready for multi-cloud strategy, then it comes to the deployment. How do you deploy to multiple clouds? Currently, there is the serverless framework. It allows you to have a common YAML description of your functions, of the deployment of your functions and the used resources. And you can use this to deploy the functions to different providers. And of course, there's also Terraform to build up your cloud agnostic deployments. So if you're interested in, have a deeper look into it. So and because I'm already over time, I've already come to the end, and just want to mention, just because you can have a multi-cloud strategy, it doesn't mean it's a really good idea to have a multi-cloud strategy just because. Focus on one cloud provider, one cloud vendor, which provides the best solutions, the best services for your needs, and only go to another cloud provider if you need a special service which is only available at provider B and not at provider A. So think about this. This was what experience of life tells me. Don't do anything you can just because you should. No. You know what I mean? Sorry. And that's it from my side. If you have any questions, please ask them on Twitter with the hashtag #serverlesswebinar. I can answer it later on. And yeah, hope to see you also in The Hague at our Serverless Architectures Conference. Thank you.
Thank you very much, Niko. And yeah, as you said, just because you can, it's not necessary that you do everything what is possible. Thank you so much, and I've really found it was interesting that that you showed the code sections which are really looking very similar between Azure and AWS. I didn't know that. So let's switch rapidly to the next presentation. The next presentation is done by Christian. And he's speaking about serverless microservices by example of Azure functions. And he's treating the question, do we speak about serverless? Do we speak about microservices? Do we speak about microservices versus serverless? Or is kind more of complementary concepts? I'm really looking forward to his presentation right now. Christian, go ahead.
Okay.
We need to switch to the presentation mode. Give me a second. One more second. Okay, here we are. Go ahead.
Okay. Hello again, everybody. Hi. My name is Christian from Thinktecture. And I will be doing 2 sessions at the Serverless Architecture Conference in The Hague in April. One is a little bit more about patterns and approaches to building microservices in a serverless way. And the other one is a live coding session where I'm actually diving a little bit deeper into the Azure Functions platform and the Azure Functions runtime. And today I want to give you a short and concise overview of those topics and what you can do by using a very, very specific and a very, very certain serverless cloud provider. In this case, I want to talk about Microsoft Azure and Azure Functions and related technologies. If you want to get in touch with me after the conference or after the webinar, please talk to me on Twitter at Christian Weyer or send me an email, christian.weyer@thinktecture.com. I would be more than happy to chat with you. Au contraire to Niko, I don't want to talk about how we could actually abstract things away in order to be able to move between clouds, but I really want to lock things into the cloud. And in this case, as said, especially into the Azure cloud. But the first part would be now talking about microservices or what's in a name. Is it really microservices that we're trying to build, or is it something different? And then I try to create a picture of how to build those microservices based on Azure with Azure Functions and how to decouple them by using asynchronous messaging patterns and technology with using and applying the Azure Service Bus. And last but not least, to sum up and to give you a sneak preview into what will come in The Hague, talking about the extensibility possibilities of Azure Functions. Great. So everybody and his mother is talking about microservices, right? But what are they? And is it really, because I hear a lot, should I build microservices or should I use serverless? Is serverless better than microservices? Does it help me in my case? Well, of course, the consultant's answer is always, it depends. But I am rather seeing approaches and ideas to build microservices architectures with serverless. So let's first talk about some of the principles of microservices. As we know, there are a lot of opinions. If you ask 15 experts, you get 25 explanations and opinions on things like microservices. I just want to talk about four properties or 4 principles of microservices. The first one is talking about that small or large thing. So the single responsibility. It should be focused around a business domain. It should be a small unit to code, a small unit to test, and a small unit to deploy. The second one is about isolation, which means I can work on my microservices or on my very microservice, and another team or another guy or another gal is working on others. I can choose my technology. Let's say I'm from the Microsoft minded world, let's use .NET and C#. The others are going to use Java. Yet another one is using Node.js and JavaScript. Of course, in order to be able to talk to others, or for me that others talk to my microservice, I need some kind of a well-defined but still technology agnostic API. Some kind of event, when some kind of event occurs, my code should be triggered. And if I do it right and I have the isolation in place, it should be quite easy to use that microservice and move it around from the local single instance environment to a cluster-based environment on premises, to a cloud provider A, to cloud provider B, into a cloud hosted multi-instance cluster. It should not make a big difference. Third one is probably the hardest one. It's to be autonomous, which means each and every microservices has its own state, which means I have a database. One has a SQL server, the other one has an Oracle DB, the other one has a Cosmos DB, the other one has just plain storage like a table storage or big table. And this is all great and nice, but in order to still have a system and an ecosystem of multiple microservices, I need a way to exchange data, but still I want those microservices to be decoupled because I want to release independently, because I want to version independently, because I want to deploy independently, and I don't want to be synchronously coupled to all the others. Of course, we always have microservices which are in the front talking to our client application or mobile apps, but the rest of the microservices, there is always a big wish and a big target picture to asynchronously communicate between those. And how could we actually achieve that if we think about the technologies at hand in the serverless world? So a microservice is a unit of independent deployment for a business domain-specific service, for sure. And maybe we could find a little bit more focused wording. I know that nano service has been around a couple of years ago, and for some it was a pattern, for others it was an anti-pattern. Let's now just define it as a good pattern. So a nano service is more or less like a microservice, but more focused and more lightweight, and can be coded, deployed, and replaced easier. So the mental model is what we call a function. So this is the sense, the basic idea of building and modeling nano services with function as a service technologies and platforms. My goal is always to make things easier to go to production earlier and not having to deal with all those infrastructure stuff that we have seen around in the past years. Which means serverless is a different approach to building microservices without having to deal with Docker and Docker Compose or even Kubernetes and all those quite complex technologies. For me, I want to do the cloud provider specific thing now. So in order to have a look at what we could do in terms of building microservices or nano services, let's take a look at what the Azure platform has to offer. And I will be talking about two building blocks. One is the serverless compute. So how does my code run? And how does it look like? And the other one is how could my code and my microservices or nano services talk to each other in a decoupled way? So Azure Functions is Azure's FaaS offering. It's actually you writing code that is being triggered by an event. And an event could be just an HTTP request. An event could be a message in a message queue. An event could be an email. An event could be some updates in a database. For that, the Azure Functions team has created two basic two basic approaches to the programming model. Let's put it like this. So an event actually triggers a so-called trigger. So your code is being activated or woken up by a so-called trigger. And then we have bindings, and bindings is a means, a technical means, a programming model means to talk to data. The recent incarnation of Azure Functions is built on .NET Core, which is A, completely open source, and B, completely cross-platform, which also means that the Azure Functions runtime is also available locally, so we can completely run it locally, we can debug it locally, we can test it locally, and we can also deploy it into our on-premises environments, including single node or multi-node Kubernetes-based environments. And we have the ability to use different programming languages and programming frameworks. Of course, there's C# with .NET Core. We can use JavaScript or TypeScript with Node.js. We have Java, and we also have Python. In the end, what happens is that the blue thing is your code now. And a code is always being activated by a so-called trigger. In this case, it's an HTTP trigger. Let's say it's an HTTP GET or POST. We can also use input bindings, which means that now, based on a parameter that comes in via the trigger, we can talk to Azure Blob Storage and just get a blob out of the storage just by using a very, very simple programming model approach. I will show you the code in just a few seconds. Then our code runs, we're doing our logic in there, and then when we are done, we want to put data out into some data sinks, like into a database, or we want to send out a native push notification, or maybe we want, even in emergency cases, we want to send out an email as well. So how could this look like, or how does this actually look like? This is a very, very simple Azure function in JavaScript and Node.js. As you can see here, the code in JavaScript is quite bare bones. We have an export, we have a context, we have a request object, and then we just get some data. But how do we actually get the data? How is this populated here? In addition to the code, we always have metadata. And inside of the metadata, we here have an input binding defined. And that input binding is looking at Azure Table Storage, because inside of table storage, we have a table called products. And based on that table, we can get all the products information sucked into the function, and we just return it as a JSON with the values for the ID and the name. And that's all. Quite simple, quite easy. So bindings and triggers are trying to encapsulate a lot of code and best practices that would take a number of, I don't know, dozens of lines over and over again for you. This one here is just another one. This time it's built in C# and .NET. You can see the function name attribute, and here we have the HTTP trigger again. This is a sneak preview because this one is accepting data through HTTP, and then it's pushing it out to a message queue, in this case into an Azure Service Bus queue. And last but not least, we have the Java example. We already saw that in Niko's presentation quite nicely. So again, we have a function, then we can have a trigger. This time it's not an HTTP trigger, but it's already looking at a queue. It's doing the super complicated logic and then putting out the data again into another queue. So this is a perfect example of completely isolated microservice operation being triggered by a queue and putting data or result data back into another queue. Okay, so how does this queue thing work? How does the service bus thing work? At the end of the day, asynchronous messaging is a perfect means for decoupling our microservices. There are two patterns at our hand, queues and topics in Azure Service Bus. Azure Service Bus is AMQP compatible, and we have Azure function bindings at our hand for all the programming languages that we need and that we love. At the end of the day, a queue is really just a queue, right? So we send a message, we get an acknowledge, it is being queued. When the receiver goes online, it gets the message and it optionally sends back an acknowledgement. If you want to have a little bit more sophisticated communication patterns like publish and subscribe, like fan in, fan out, you could have topics and subscriptions. So on the left-hand side, we have the sender. On the right-hand side, we have our subscribers. And depending on what type of data or what type of header we have inside of our messages, the messages are routed to different subscription targets. It all is available inside of Service Bus triggers if we are being triggered and activated by a Service Bus queue or subscription, or we can have Service Bus input or Service Bus output bindings. Okay, so this bindings and triggers thing seems to be a very, very central and very, very important part, and actually it is. At the end, there are a really, really big number of already existing and pre-manufactured bindings, input, output binding, triggers. Always the need to create your own one. So we can create our own input and output bindings. We can also create our own triggers, but with some limitations. I will talk about that at the conference in The Hague. So if you want to know the details of that, let's see each other at the conference. So if you, for example, need to talk to some very, very specific ERP system or internal system that doesn't have an open API, you could create your own bindings or even triggers. If you, for example, want to send out notification data not via native notifications, but via the quite new web push protocol, which are basically used in progressive web apps, you could create your own output binding for your Azure functions in order to quite easily write new functions that do the push via the web push protocol. As said, I would be very, very glad if you would be joining us all in The Hague at the Serverless Architecture Conference. I want to thank you for listening. If you have questions afterwards, please use Twitter with the Serverless Webinar hashtag. Thanks, everybody.
Cool. Thanks so much, Christian. I was kind of surprised. Did I get you right that I can use the Azure Functions runtimes even locally as soon as I got a latest .NET Core on my machine?
Yes.
That's surprising. Wow. Okay, cool. And as Christian already just said, use the hashtag Serverless Webinar if you want to raise a question. And if you want to raise a question right now, just do it. Yeah, we collect the stuff, and then afterwards there's still some time to discuss further questions. All right. Then let's just skip to the next presentation. This one is by Billie Thompson. And the title is, What's the Future of Open Tracing? If I understand it right, open tracing is a standard and a tool hosted by the Cloud Native Foundation, and it helps you to, let's say, to understand the behavior and the communication paths inside of a complex and distributed system. Now we're waiting until the presentation is open, and then we can switch. So Billy, go ahead, please.
Hi, so I'm going to be talking about the future of open tracing today. Just so you know, if you've got any questions, you can see in the bottom left, there's my handle on Twitter and also the hashtag. Okay, so I think in order to understand what the future of open tracing is, we probably need a bit of a description as to what open tracing itself is. And because it's pretty tightly coupled, I'm going to talk about what distributed tracing is too. Okay, so for most people, this is the internet. It's web browsers. Maybe if you're a little bit more technically savvy, you know that web browsers talk to a server, and you get a web page back. But actually, the picture is quite a lot more complicated than that. So there are usually hundreds of servers behind even a relatively simple service. By the way, I'm going to talk about servers throughout the whole of this, and I don't really mean servers. I mean microservices, I mean nanoservices, I mean like functions, but I do also mean servers. You can apply these techniques to regular servers as well. Okay, so I want you to imagine this architecture inside a software house somewhere. So a request comes in. It then goes out to another web service, which writes something to the database, and then it calls another web service, which queries a secondary web service, and then we call another web service, which also reads something from the database, and finally it calls the same web service again. So there's a whole bunch of requests going on here, and it can get very confusing, particularly if you're the server on the top right of the screen there, where you can see the multiple requests coming in from different places. So how can we demystify what's going on here? So open tracing is a project which attempts to define some key concepts which allows us to simplify the tracing of requests through specific services. Now, each one of these colored lines is what in open tracing we call a span. Now, a span can be think of as a request. So a span starts when a request comes in and it finishes when a request ends. It's a little bit more complicated than that, as it can also be in-sync function calls. We call the entire thing a trace. And what happens with these spans and these traces is after a certain, we write them to a server, which co-locates them into a single place. It's worth noting that this collection part isn't part of the open tracing specification. It's just a really common implementation. In fact, I don't think I've seen any serious implementation which doesn't do this. Now, I'm sure you're thinking that won't that swamp that server? Well, this only happens if you set special headers on your set a specific probability to write them to. So is on production systems, I would set the probability that a trace is going to be saved from a request to, say, 1%. And then I have some insight into what's happening on live. And then on development mode, I set it to 100%, so I can see every single request. So what we do with this information is we build a hierarchy, which looks somewhat like this. It's a tree. So we've got the base span at the bottom there, and inside we've got the 3 smaller spans. And then slightly further up, we've got the even smaller spans on top of that. And we pump these into a software which will draw a pretty graph like this. This is Jaeger, which implements the open tracing for its API, for its client APIs. And it gives us a really nice way to feed data into something which can give us great observability into our microservices, nanoservices, functions. So because there's always some meta information that you need to know about specific requests to make this useful, we can provide this with tags. So a good example of this is the HTTP method. So you might want to provide the method, so get, post, put, options, patch, or the URL. And this all gets fed into the span and gets sent back so you can identify the request again. We also have logs, which are things like stack traces. And also error messages, and they have timestamps and stuff like that. There's not loads of these. And finally, we have baggage. Now, baggage is not typically used by the end users of the API, but it contains implementation-specific details that need to travel across service boundaries. So span ID, trace ID, parent span ID are all the ones I see typically in implementations of this. Okay, and you can put anything else in there, but it's just not typically done. So the key thing to know about open tracing is a client-side interface which allows you to do this. So it's not a server. It's not necessarily a call library. It's not a server standard. It is a client API specification, and it is a set of common keys for tags and logs. And it's kind of an attempt to prevent vendor lock-in while still gaining all the benefits of those tracing software that you want to use. Okay. But you didn't come here to listen to me talk about what open tracing is at the moment. You kind of want to know what it is going to be in the future. So this is a really hard task. So in order to kind of illustrate this, I want you to think of a number, and we'll see if it's going to be the number that I'm going to show next. Got a number? Cool. So I'm guessing that it probably wasn't this number. Well done if it is. This is the lowest of the uninteresting numbers, by the way, just so you know. Okay, so in order to make our predictions a little bit more savvy, we kind of need a bit more evidence. So where else can we look? So I was recently reminded of this quote: "Those who cannot remember the past are condemned to repeat it." Now, I know a really interesting fact about brains. Now, when you remember, say, a really happy memory with your brain in a situation which is really, really scary, it will taint that memory with the feeling that you're experiencing at the current time. So every emotion is altering, and feeling and thought is altering your current memories. So really, no one can remember anything. That means we have a perfect source for what is going to happen in the future if no one can remember, if people are doomed to repeat it. Okay, so I want to take you back to 310 BC. And I want you to meet Theophrastus. He's a Greek philosopher. He lived until he was 85. He came from Lesbos, lovely sunny place. And he's best mates with Aristotle. In fact, he's the godfather to their kids. He also ran a school. He ran Aristotle's school after Aristotle died. Okay. And he had this idea. He had the idea that the Mediterranean was filling from the Atlantic. And much like any good scientist, he thought, well, I'm going to go out and try and prove my theory. So in order to do this, he came up with his own tracing model. And his tracing model was this. So what he did was he put his mobile phone number down into a whole bunch of glass bottles, and then he lobbed them in the Atlantic Ocean. So once they were in the Atlantic Ocean, he hoped that one would float through to the Mediterranean and prove that the Atlantic was indeed filling the Mediterranean. There is unfortunately no record as to if he actually got a phone call about this. Obviously a little bit early for phones, but we don't know if it was a success or not. But I did find out that actually 5.3 million years ago was actually when that wall broke down between the Mediterranean and the Atlantic, and the Mediterranean was filled up from the Atlantic. So there we go. Okay, so let's talk about something slightly less ancient history. It's 1987 AD. I want you to meet Van Jacobson. He came from the United States. He's still alive now, and he's really famous for solving some really tricky TCP congestion problems back in the early-ish days of the internet. He's frequently credited with saving the internet, but he vehemently denies this. Okay, and he's got this really good quote, which I think is super applicable to our serverless functions as a service world at the moment. And it is this. So you get log files when things failed, but that doesn't really tell you what's actually happening on the wire. Now, Van Jacobson's solution to this problem was traceroute. You've probably used traceroute if you've faffed around on the command line. So this is how it works. You make a TCP or UDP connection, and you set a field in the TCP or UDP connection, there's a time to live header to 1. And it will go one host, and then that host will say, actually, that packet time exceeded. And then it'll do it again and again and again. And what this allows you to do is trace the request through the system by getting these additional packets which are generated when a packet is dropped from a particular hop. So what I'm trying to get across here is that reporting progress as a thing from multiple hosts as a way to get insight into multi-server software is something which works and is going to continue to work into the future. So we're not going to see any massive shifts there. So let's go back to talking about what's going to happen in the future. So where are we going to go next? Now, Simon Wadley created this evolution map. Now, Simon Wadley really loves maps, so I strongly recommend reading some of his articles about what the difference between a map is and what makes a map, but they're very interesting, good rants. And it has these 4 stages. So we have Genesis, custom built, product, and commodity. So we can use this to predict where the open tracing and distributed tracing market probably will go in the future. So initially we have Genesis. Now Genesis is characterized by these things. So rare, poorly understood technologies, like as a whole, in a whole community. Maybe there's individuals who understand it really well, but this is about the whole community. And it is talked about in articles with terms of wonder and amazement, like it's the best thing since pre-sliced cheese. And for open tracing and for the distributed tracing project generally, this happened with Dapper's Google's DAPA paper in about 2010. And this was the thing that really kicked off all the ideas going on from there. And next we have the custom build section. So here we have the technology becoming slightly more common. Things are rapidly iterating. People are changing things. People are coming up with new ideas. And publications are talking about how you can get this in your software, how you can build it yourself. Now, in 2010 to 2011, I was actually doing this in BSkyB. We had our own little tracing system. So like you can kind of see, like we're seeing a transition here up that graph. Okay, so we get to where we are now, and this is the product space. So in this space, the actual technology is relatively common, and finally, it's actually fit for purpose. So publications talk about how to install it, not how to build it, and you'll hear people talking about integrating it, and there'll be loads of different options out there. Okay, so for open tracing, kind of the journey for the products is this. So around 2000 and something, Twitter had a tracing program called Big Brother Bird in order to work out why they kept seeing the fail whale on their site all the time. Eventually, this was superseded by an internal project called Zipkin around 2002, and this was kind of put on out there for about 3 years before it was significantly rewritten to release open tracing. To release OpenZipkin, and finally, inspired by this, Jaeger was released. So we can kind of see there's kind of starting to be a whole slew of products out there. So where are we going to go next? So next we have the utility or commodity section. Now in this section, it's unusual if you don't do it. So think how unusual it would be if you came into a house and they didn't have any light switches. They didn't have any electricity. So, and much like you know how to turn on a light switch, you'll know how to use the software as it's in this section, but you maybe don't know all of the internals. So a good example of this is databases. And finally, publications kind of talk about how to use it, but they don't necessarily talk about how to install it or how to get it or how to make it from scratch. So what can we say about open tracing? Now, open tracing fits really nicely into this bridge area between the commodity and the product space. Now, for me, it did release a little bit early, but that's sometimes a good thing. So what is the future of open tracing? Because I did promise you concrete examples just before the end of this talk. So what is the future of open tracing? I could be like kind of junky and say, oh yeah, there's going to be more traces and it's going to support more services, but everyone knows that, right? I think what we're really going to see, which is interesting, is it's going to be being embedded in more and more places, and you're going to be able to plug in your tracer into more and more interfaces and just have tracing through more of your stack. So we're already starting to see this happening with Knative providing Istio and also a tracing package, so you can actually start tracing things in your microservice serverless infrastructure out of the box without really having to do any code, which is really cool. And this is already in Cloud Foundry, so it's kind of being implemented already. We're starting to see this growth. And as competition dies down, people will want more standardization. So we've seen quite a lot in the previous talks about how people really want the ability to deploy their code in multiple different places without too much effort. And finally, I think this is kind of going to be a summation of open tracing. You will hear this fantastic, amazing talk by someone talk about the coolest bit of software you've ever heard of. And they will just briefly in passing go, oh yeah, we're using open tracing internally. So it's going to become less visible. It's going to become more of something which is just on the day-to-day basis that we use. Okay, so that brings me to the end of the talk. So if you've got any questions, tweet at me and use the hashtag. And if you would really like to learn a lot more about this, please come see me at the Serverless Architecture Conference. That would be amazing. Thank you.
Cool. Thank you very much. So now after having heard all the 3 talks, there is an opportunity to raise your questions. And as I'm always a curious guy, I'd like to start from my side. Niko, you were talking about the idea of neutrality or vendor lock-in and in trying out what is possible. And you spoke about applications and functionality, but how about data, if we speak about the cloud world? Is it totally different? Should I, when it comes to data storage, when it comes to data streaming, etc., should I then approach more a serverless or a vendor-independent approach or not? Or is it something different? Or would you just say it's the same thing for applications and for my data in my company?
I think it depends. Typical consultant answer. I think it depends where your data is stored and how it is stored. When you're in AWS Cloud and you're using, for example, Kinesis streams, it doesn't make sense to use Azure functions to operate on the Kinesis streams, because it's really simple to register Lambda functions on a Kinesis stream and to process the events in Lambda, and not to have a processing of the data in another cloud. That's all the event processing in one cloud provider is built up on these events, and you can easily register a Lambda function on a Kinesis event, on a DynamoDB event, or on S3 event. And if you want to process these events, you should stay in one cloud. In case of HTTP events, perhaps it makes sense to distribute the services. If you, as I already mentioned in my talk, if you have the need to consume services which are only available in one cloud and not in the other. Yeah.
Okay.
That's a thing, I think.
Yeah, cool. Thank you. Then I'd like to move forward to your speech, Christian. If we speak about a little bit more about, let's say, patterns for nano services or functions, as you call it, and traditional microservices, is there, or maybe two questions, do you see a difference in let's say, in the granularity of those, let's say, services? Is the one thing bigger and the other thing smaller than the other? That's one thing. And secondly, some people say, okay, especially the serverless and function as a service world is more for the, let's say, for the glue code to tying together, let's say, existing managed services or stuff like that. Do you share this pattern, or would you like to add something to that?
Okay, so to answer the first question, yes, there is a significant difference in granularity, right? For example, in Azure Functions, you could use a function inside of a Docker container to deploy that function in that Docker container to the Azure Functions runtime. But then that's just one single function, which is, of course, a very, very low and very fine granularity. If you are building your microservices, let's say with barebones.NET or barebones Java, or even an abstracting framework on top of that, then you build some kind of service with an API, maybe HTTP based or maybe message queue based, and you use that .NET assembly or that Java, char or var, and then you deploy that or run that in your in your Docker container, and then you deploy that Docker container into your cloud environment. So that means, of course, there is a difference of granularity between a serverless approach when we talk about the programming model, right? Because we always have to make the distinction. Are we talking about serverless as function as a service, which is the programming model, or are we talking about serverless as serverless operating model? Because that's what we are seeing as well with Kubernetes and similar things. They are also now moving away from this explicit cluster management and failover and master and slave. Things like Istio and things like Knative are going exactly down that road, having a serverless approach, but with a hosting model, which is great and which is good and which will be the future, I think. But the other side with serverless as a function-based programming model, FAAS, is not suited for everything.
So you'd say, okay, this is let's say these are complementary concepts on the one hand.
Exactly, yeah. So I see the cloud offerings as a continuum, right? Here you have IaaS, here you have PaaS, and here you have serverless, and then you pick and choose. And what was the second question?
The second question was, oh, sorry, I also missed the point. I'll come back to you. I'll come back to you.
Okay, great.
So Billy, you also explained using this Wadley maps, and he's also a big fan of the serverless approach, yeah? While using these Wadley maps, because it shows you the way, as you showed us, towards something becomes a commodity. This has a different role than in the game than if it's a product or something like that. So all this conversation about microservices and functions, all this stuff, they are happening, as far as I understand, in the frame of this commoditization. So we don't want to mess around with containers itself anymore, but we really want to have a let's say, high-level, highly abstracted environment where we can do different things, right? So where do you see the serverless debate in general? Because you pointed out with open tracing in this curve at the moment, yeah?
Yeah, so how I feel about kind of the serverless debate is that it actually is starting, we're probably beyond the genesis phase these days, and we're probably getting towards the end of kind of the productization, because what we're starting to see is across the market, a lot of people that even maybe 6 months ago didn't know about serverless are starting to know about serverless and starting to get interested in it. So we're starting to see that kind of ubiquity increasing. However, it's not quite at the stage where people don't need to know how functions as a service, for it to take an example, actually operate on a day-to-day basis. So we're still pretty squarely in the product space if we look in the characterizations that Simon Wadley attributes to each of the phases. So I would say that, like, over the next few months with the serverless space, what we're going to see is ever-increasing ubiquity through conferences like this one, and kind of a growing knowledge of how to do them, and we're going to slowly move up that product graph. So although, like, the computing is in the utility space, the actual product itself is not quite there yet, I don't think. Yeah, so that's kind of how I feel about where serverless fits into the Wadley product evolution map and Wadley maps generally.
Okay, cool. So Christian, the second question that came again to my mind. I wanted to talk to you and to the other speakers as well about, let's say, some patterns where to look into, let's say, serverless and functions, and on the other hand, where to look at applications in the sense of microservices. Yeah? Again, there's a saying that this is more the glue code for existing high-level services, high-level managed services, which are already there. So would you just say, okay, if I want to glue, I don't know, this data service and this API to each other and make a quick and dirty solution, I should use function as a service. And if I build a real applications which represents the core business of myself, of my customer, is this something like that, or what would you say?
So if I see serverless as function as a service, then yes. It's not quick and dirty. It's more productive, right? But yes, the idea of, at least in Azure with the triggers and the bindings, is exactly made for getting data out of data sources and putting data into data sinks, right? That's exactly what it is made for. If I want to build and if I maybe want to migrate existing systems from on-premises into the cloud, and maybe from a single instance model to a potentially multi-instance cluster-based model, then functions is surely not the best way and the best approach to do this. Then I would rather look into a Docker-based approach and then deploy that into a cloud provider service or system like AKS, when they are going to be more serverless in the operation model, because today it's just a pain in the neck to operate Kubernetes and to even use AKS in Azure and all those, how's it called in AWS? I don't even remember. So I think it's way too complicated for moving an application into the cloud and then to operate and monitor it up there in one of the cloud providers. We still need a more serverless operating model as well.
Okay. Christian, would you like to add something?
Yes. I think serverless and functions are a perfect approach if you want to process or have the need to process events and data asynchronously. For me today, the servers or the functions are not ready to serve user-facing requests for general purpose, because you have this thing called startup latency, cold startup latency, with this with Christian's words, pain in the neck. Especially if you have Java runtimes, you have to take care of many things to reduce this startup latency. And so if you want to use functions for HTTP requests, user-facing HTTP requests, this can fail at any time. So I think serverless architectures is perfect for the asynchronous data processing.
Okay, cool. Last but not least, Billy, I'd like to understand a little bit deeper. You showed us the example with the message in the bottle. Maybe you got another, let's say, example from today where you got an existing system and what you can learn from using this tracing mechanism.
Yeah, sure. So previously I've worked with systems that are very complicated and somewhat fragile, and one low-touch way that we have had to fix this has been to use the Java Sleuth library. Now, the Java Sleuth library is really cool because it gives you all of this tracing for essentially free. So what you can do then is if a large portion of your services are in a somewhat fragile state, then you can take a request and then drop in a single dependency and then instantly get all this tracing throughout your system. So what this means is you can then see which of the requests is taking a really long time, which might be quite mysterious if you do things like going in and out of queues. This is kind of the situation where you'd want to use that, where you have a complicated architecture and you want to minimize that. It's also really important for kind of like those day two ops, where you're working about how you're going to monitor and observe the system to increase observability. So in practical terms, what this looks like is for every single request, you add in some HTTP headers. For your packets, you add in some, for your queue messages, you add in some additional messages to your queues, and then a library inside the code will pick them up, and then that will report back where exactly a specific request has gone through in your system. And like, depending on the language, you have assorted levels of like how much work you have to put in to do that, but it's usually really, really light touch, where you essentially just have one function call at the start and the end of a specific bit that you want to call a span. So that's kind of a practical example of where you might want to use it. You could probably use it to replace logging if you really wanted to, and just keep the errors in the logs, like the Van Jameson quote.
Yeah, thank you very much. And again, for you listening and watching this little webinar, please mark your calendar. We run the conference serverless-architecture.io on April 8th to 10th. Lots of cool sessions, lots of conversations like this one, even deeper because we got more time, we are more speakers, etc., etc. I hope this made you curious, and I would like to say a big thanks to all the speakers. And thanks, of course, to you watching us and spending your time with us. And don't forget that we got the free promo code Serverless Webinar 19 you can use for 10%. So, dear speakers, thanks for joining us, and see you in The Hague, right?
Yeah. Yep. See you.
Yeah.
Bye-bye. Bye-bye.
Bye.
Bye.